Yeah, good afternoon. Thank you very much, Andy. And good afternoon, everyone. And my name is Qihao Jin. I'm from Rheoo, GmbH. We are based in Germany, Karlsruhe. And now today we are talking about, I'm going to talk about inkjet-printed optical coatings. Some few words about our company. So we are based in Karlsruhe region, and we are a spin-off from Karlsruhe Institute of Technology. And our business model is very simple. So we produce optical coatings, and we also provide optical coatings as a product. And our coatings includes the anti-reflection coatings, as partially coated, or patterns, or uniformly coated. And we also offer normal spectral filters like dielectric filters and so on. And these optical interference coatings, maybe not everyone's familiar with that. And just imagine that you have a piece of pancake. And usually the thickness of the pancake is like millimeter thick. And now if we come to the pancake of optical interference coatings, each layer will be several tens of nanometers up to 200 nanometers. So very thin. And inkjet printing is usually challenging to achieve this thickness precision. And in Rheoo, we do that, and we achieve these nanometer precision in each layer. Rheoo developed its first of its kind optical interference coatings by inkjet printing. And we made it customizable and affordable and sustainable. And customizable in terms of substrates and shape of the coatings and the material of the coatings and also the functionality of the coatings. And since we do inkjet printing, so we don't need vacuum chambers like what you need in the PVD or CVD production line. And but we can, at the same time, achieve the same nanometer thickness resolution as PVD does. Also, we inkjet print thick layers and thin layers, both maintain this thickness resolution. And as a natural property, inkjet printing is a digitalized printing process, and we have a lot of choice on the material, the inks. And also, inkjet printing is very suitable for large-scale production. And yeah, this is just a page about myself. And I'm the CTO of Rheoo GmbH. And the name Rheoo actually is because we do inkjet printing, so it's a rheology. So it's more rheology optics, so more straightforward. And happy to chat after the talk. Okay, a little bit background of the inkjet printing. So inkjet printing, we use, in Rheoo, we use piezoelectrical technology, and we control the ejection of the droplet by customized or optimized waveform. And this is also so-called the drop-on-demand printing technology. And the ejection of the droplets, it includes a lot of these rheological properties of the ink and the liquid itself, such as the surface tension and the boiling points, or A, B, C, and Z. So you can see there's a lot of parameters included. And also, this is not only about the rheology itself, it's also about the ink itself. So here we're talking about these optical inks, which is transparent in the desired wavelength range. For example, if we want to make coatings for the visible range coatings, then we usually make it in the visible range, low absorption, basically near to zero absorption. And this is also one of the critical demand of the optical coatings, optical interference coatings, in the visible range application, that you have really low absorption in this range, and so the light comes in and either reflected or transmitted. So these coatings are always used in the high-end optics and photonics. Of course, there are so many factors that can affect the inkjet printing and the final printed optical products. And it includes the jetting of the droplet, and also includes the deposition and how to uniformly form the thin film on the substrate. We just have a deeper look at the precision and the potential of the inkjet printing. So actually, the droplet positioning of each droplet is very, very critical. And we successfully we can achieve the similar results as here. So you can see